We have an adiabatic CSTR that's not at steady state. So the volume is constant, the feed rate is constant, we're given the conditions, and we're given the initial conditions of the reactor. So it's at 325 Kelvin and a concentration of A of 5 millimoles per cubic centimeter. Given other properties such as heat of reactions, first order reaction. And the question is, if we started these conditions, does the concentration of A in the reactor increase or decrease initially as it approaches steady state? So steady state concentration is some other value than 5 millimoles. How does it approach that steady state? Turns out for this problem, what we really are asking is what's the derivative concentration of A with respect to time? And so if we look at a mass balance, we have an accumulation term, and it's a constant density system, so we're going to write as the volume of the reactor, which is a constant, change in the concentration of A with respect to time. This is what we want to determine, just its sign. And so that's equal to the volumetric flow rate times the concentration coming into the reactor. The volumetric flow rate's constant, concentration leaving the reactor. And then the rate of reaction, so it's first order, so concentration of A in the reactor is the same as the concentration leaving the reactor times the reactor volume. So essentially we can substitute the values into the right side of the equation to determine whether the right side is greater than or less than 0. So let's look at the values. The volumetric flow rate is 250 cubic centimeters per second, and we'll factor that out. And so the concentration coming in is 10 millimoles per cubic centimeter, and leaving is 5, so millimoles per centimeter cubed. The other term now is the rate constant, 10 to the 11th exponential. And now for temperature, we're going to use the starting temperature in the reactor, which is 325 Kelvin, and the concentration in the reactor, which is 5, and then the reactor volume, which is 50,000 cubic centimeters. So we need to check that the units are going to be consistent, and I forgot to write the units down. Seconds to the -1 is the units for rate constant. As you can see, we're going to end up with millimoles. This term, cubic centimeters, cancel, millimoles per second. Likewise here, millimoles per second. So if I calculate these values, 1.25 minus 1.08, 0.17 moles per second, greater than 0. Therefore, concentration of A with respect to time greater than 0. And so the question is, what happens to CA? Does it increase or decrease? This says it increases initially as it approaches steady state.